You might have seen this clip from Jensen, CEO of NVIDIA, floating around about the relevance of programming in an AI-powered future.
I'm going to say something, and it's going to sound completely opposite of what people feel. Almost everybody who sits on a stage like this would tell you it is vital that your children learn computer science. Everybody should learn how to program. And in fact, it's almost exactly the opposite. It is our job to create computing technology such that nobody has to program, and that the programming language, it's human. Everybody in the world is now a programmer. This is the miracle of artificial intelligence. For the very first time, we have closed the gap, the technology divide. You can imagine everybody in your company being a technologist.
Let me tell you my three main reasons why I think Jensen is wrong here and why you should still kind of learn how to program. For those that are new to the channel, I'm Yassine, a published researcher and machine learning practitioner who loves to teach. My first point is that programming is not about coding. This is what Jensen is mixing in his assessment of whether programming is a useful skill to learn. There's a difference between programming and coding that isn't obvious for people that aren't familiar with the field. Coding is the process of writing instruction for a program, while programming is the process of designing and developing a program. Like a junior programmer will not separate the two, because like coding and programming for them is the same thing. You sit on a computer and then you just kind of write lines of code, which may or may not work, right? And you're doing your work like this. Somebody that is more experienced, for them, there's a difference. And like most of the programming happens without touching a keyboard. What I mean by that is like coding is like this subset of programming in general, where you're creating like machine readable input, you write line of code. It's all about like the language that you're using, the syntax, the library maybe. And programming in contrast is like very vast. And you create and develop like program, but you have to kind of develop them. It's all about like debugging and testing if like the code that you wrote is matching the logic that you had in your mind. So this is why you have logic errors. It's because the program and then the code, the implementation are mismatched. It's about like translating requirements that you may or may not know. Some of the requirements are not already spelled out. It's the context that you kind of need to develop the skills of asking questions and like getting it out, or like inducing it from how the code base is structured and stuff like that, or what the future roadmap look like. Lots of documentation in there, analysis, talking to stakeholders. If you develop something complex enough, you're gonna see the difference between the two. And if there's something that you're building that is lasting in time, you will also see that difference clearly, because you will kind of feel it. Sometimes when you want to add a new feature in the existing code base and you have it in your head, you kind of get this feeling that like it's gonna be easy because I already know how we're gonna like structure it. Or sometimes it's like, yeah, it's gonna be hard, and you haven't written anything. It's just like the shape of it that you know how to make fit. And sometimes like you just need to do a few transformation in your head or on paper in order to understand like how to go from the requirement to the shape that will fit into your code base. To further this point, let me show you an interview with Francois Chollet, an important figure in AI, talking about this difference.
Is there a world in which all the programmers are replaced and then we're still saying, but they're only doing memorization-laden programming tasks, but they're still producing $1 trillion of worth of output in the form of code?
Software development is actually a pretty good example of a job where you're dealing with novelty all the time. Or if you're not, well, I'm not sure what you're doing. So I personally use generative AI very little in my software development job. And before LLMs were a thing, I was also using Stack Overflow very little. Some people maybe are just copy-pasting stuff from Stack Overflow, or nowadays copy-pasting stuff from an LLM. Personally, I try to focus on problem solving. The syntax is just a technical detail. What's really important is the problem solving. Like the essence of programming is engineering mental models, like mental representations of the problem you're trying to solve.
My second point is that the programming concept you learn are tools that help you structure your problem-solving motion. This is extremely valuable, irrespective of whether a solution gets coded or not. Most of programming is in a sense just about giving the problem and the solution the right shape to get to a correct answer. The structure helps you clearly see what needs to be solved and what needs to be fed where and in which format. Being good at this allows you to think of solutions to problems that are simpler to formalize into a computer. that problem-solving skills is useful even in non-computer related situations. It helps structure your thought and give you clarity. It allows you to see a repeatable pattern of problems and understand how to modify input-output to get to a simple solution. Okay, so here an example, like a supply chain flavored example of what I mean by just the programming concept being helpful for you to structure your head around a possible implementation of something. Let's say you're developing an app to help buyer and supplier exchange information a bit easier. So a very naive take of this is that you have a buyer and you have a supplier, and then you're trying to exchange information. And in this case, like you know that you're gonna have information being exchanged over here, let's say an email, right? And then you get a response here, another email, and then that's it. That's kind of the way you're gonna do your stuff. If you think about it a bit more, you see that like a buyer has many suppliers, right? So then you start to have many of these email being sent together, and you start to realize like, hey, maybe that's not the best way to organize our back and forth. So this is a very buyer-centric view. Like if you were to design an application at this point for a single buyer, this is a very correct view to have. If you're trying to design a solution for multiple buyers and multiple suppliers together, this view is not exactly correct because you only have one buyer. So if you add a few other, right, you start to realize that the shape of this start to kind of take the form of something that already exists. So this is a bipartite graph. So yeah, it's bipartite because you have buyer on one side and you have another type of node on the other side. And then these two nodes are connected, but they are not connected within themselves. So if you were to design an application to do the exchange of this information, you will realize that like, okay, we can maybe send email back and forth over there, but there's some suppliers that will receive multiple email from multiple party. Maybe it would be best if like these suppliers had a way to kind of manage all of this influx of emails that are coming into them. So you can start to see that like, let's say this one is starting to become a hub of all of the different elements, and this one receives absolutely nothing, right? If you push a bit your idea further and start to really think about, okay, you have these suppliers, but like they don't buy anything, these ones, like it's just like them that are supplying, they're a pure supplier, and you start to kind of look at the constraint and like look at the requirements for building an app that will kind of encompass all of these, you get the following diagram, which look a bit like this. These suppliers are also buyer from other suppliers, right? Like in an industrial supply chain context, everybody's buying, everybody's supplying in some sort of way. Even these ones, like they're gonna supply to some customers over there, right? And they have different names. So here you have an OEM, you have a tier 1, a tier 2, and like this tiering is with respect to a buyer. So it's still buyer centric, right? So you have, let's say this buyer, and these is tier 1 suppliers, and then this is a tier 2 supplier for this one, and so on and so forth. And you see that like this kind of bipartite graph structure is starting to repeat itself. And you see now this one, okay, like is a supplier for these, but is also a not too bad buyer for these ones over there. So if somehow you made a system that was helpful for this supplier to respond to his buyer, or to be able to buy at the same time and have like all of this technology to like exchange information properly, and that is enjoyable for this one as a supplier and for this one as a buyer, you can get a good adoption. If this one adopt the system, there's a very good case to be made that like other ones will adopt also. But then you look at this and then you might think about like, where does it end, right? Where is the tiering ending? And if you push your reflection a bit and you gather the constraint again, you realize that this is not an actual good view. It's a very buyer-centric view. It's a very OEM-centric view. But if you were to design an application for the whole supply chain, it's not maybe the right mental model to use. That model start to make a bit more sense. And this is an actual directed graph. It's a graph because there's no real beginning or end. It just happens that there's nodes and they're connected together. And if you see now, there's nodes that are bigger, right? And there are nodes that have dual type of parameters. So this node has a buyer persona and a supplier persona. These ones are just buyers. They don't supply, or maybe they can be a little supplier for like the customers. And you can see these weight of exchange of information. Some of them are bigger with some buyers, some of them are smaller, right? And then you can see also that like this big buyer is also, this big supplier is also a buyer for like these smaller entities. And these smaller entities are not gonna shrink to nothingness. Maybe there's a big supplier of, I don't know, raw material that is supplying to everybody, and that is super small over here. And but this one also need to buy stuff, and then you can see like the supply chain is actually more of a supply mesh that is starting to get structured. So if you have the same exact application of like helping out do the exchange of information between like the buyer and suppliers, you start to realize that like there's different shape that you might need to take into consideration. So you really want to get this guy over there on the platform because the surface is big. Here you see there's a big volume. Here it's maybe a bit less relevant for them because they don't buy as much or something like that. They do a lot of stuff in-house, but you see that still it will be useful for them. You see that these ones have a big supply aspect, but they might not care directly to manage it. Maybe they have, let's say, like portals over there, or like EDI platform or some sort, and then they just don't care about the smaller one because it's a big supplier, and then these are very small buyers. Versus these one, which has like a good size of buyer, but like the suppliers are like modest in terms of size. And you start to kind of structure a bit your thought around it that is a bit more related to reality. Still, this is very manageable for building softwares that will be translating well into an application that will be useful for a customer. Also, if you're completely new to programming, I highly recommend Brilliant, which are kindly sponsoring this video. Brilliant is a website with a lot of interactive bite-sized lesson and problem to solve. They got quite a few interesting beginner topics if you want to refresh or supplement your learning. I've gone through mainly their programming course and their math course. It's a very good introduction to the material. It's nice because you see both the programming side and the coding part of the craft. They're kind of like well separated. It's also structured around like making micro program without overwhelming you, the beginner, with jargon and syntax. They also cover advanced math topic and even LLM in some of their other modules. Do check out the link in the description to test it out for 30 days and get 20% off their annual subscription. Okay, lastly, a strong programming background makes you better at steering the AI where you want. LLM right now are great at producing code in a constrained environment. You still need to gear them in the right direction. Sometimes, yes, they do hallucinate, but if you have a good enough vision of what you want to build, they are a very helpful copilot. The more precise the context, the more generally solvable the task, the better they are at generating a solid working piece of code. However, LLMs are not going to figure out for you what you should be building. They won't figure out by themselves the unseen context that is business critical and add it to the requirements. They won't understand what context has become suddenly irrelevant mid-project either. And they won't plan and formalize the solution in a way that makes sense for the specific stakeholder in like your business or your consulting project. If we recap here, like LLM's really good at this, right? So far, not that great at programming, especially because like there's context, there's choice to be made, and there's a high correlation with the future, which the LLM can't see. But us, we can kind of plan and like anticipate it. So LLM very good at this part. And if you are not careful, especially with bigger and bigger code bases, where the context is a bit difficult for the LLM to grasp, you might get into a project that looks like this. Problem is that my project becomes so big that Claude can't properly understand it. So they say I made a Python project actually using Cursor and Claude, but that's gotten to the point that the whole code base is like 30 Python file. Code is super disorganized, might even have duplicated loops. Claude kept forgetting basic stuff like import at this point. When I asked to optimize the code or to fix a bug, doesn't even recognize the main issue and just end up deleting random line or breaking everything completely. You see, like this is the kicker, right? I have zero knowledge about Python, right? That's the issue here. So it's actually a miracle I got this far with the project, but now it's almost impossible to keep track of things. What do? I already tried using cursor rule, but doesn't seem to work. The truth is, there's something that got lost during the process, which is the context the context is out of the window because you even don't know what the context is anymore. So you can't expect an LLM to do like the programming part. So Jensen, I don't know. I don't think this is what you want, right? This is not the type of future you want. I think a strong programming base will make it much easier for you to know how to cut the context to feed it to the AI system, especially if you have strong functional programming skills, as the code in that sort of programming is much easier to compartmentalize. Stuff like functional React component, like single Python script that are well bounded, clear function, are all things that an AI system excel at developing right now. If you couple all of this with a solid domain expertise in whatever subject you're working on, you're gonna be very, very productive. I hope you enjoyed the video. Don't forget to like if it was the case and leave a comment if you have any question. I'm here to help. Have a great week everyone and see you in the next video.